Good morning, everybody. Thank you very much for joining us here. It is my pleasure to share some of the things we've done during the year with you. I'll try to entertain you with some interesting news. I will try to be careful so that everybody can understand. And if at any time there is any questions that you have or any comment, please feel welcome to ask your question. So I will first speak about the new version that we have just released, and I will give you a demonstration of how it works also. This version, first let me introduce Magsoft. So we'll be backwards like this, but we'll get there. So that you know, maybe some of you have already seen this picture here, but this is just a picture of where we are located. If I look, this is the map of New York State. Right there is New York and Long Island, and then inside there is Boston. Up there on the top is Montreal, and we're right here in the middle, at about the same distance between Boston, New York, and Montreal. So if you ever go to any of those cities, feel free to come and visit us. We're just on the south of the mountain, and as such, we are in a very cold place. And in fact, tonight it's going to be -1 at my house. A little different from Taichung, for sure. And in the winter, we actually do quite a lot of snow, and so that's what we do when we don't know what to do with the snow. So we're going to talk about Flux, and I think most of you know it, but I thought it would be important to actually try to remind you of what we can do with it. And so it's a finite element tool, and it's quite versatile. You can solve any type of structures, from the smallest one, which is here. This is a recording head from a very long time ago, but we still do recording heads, so very small. We talk about several microns, maybe nanometers, very small air gap, and fairly long structures, where the materials are very important, to very large structures. This is a boat, and when the boat is inside the magnetic field, Earth's magnetic field, it creates a distortion to the field that would make it seeable by somebody who has a magnetometer. So the Navy of the world are very interested in making their boat as stealth as possible, so that's with noise, with sight, but also with magnetics. And so we work at creating coils to cancel the dipole effect brought by the boat inside the magnetic field, terrestrial field. Right here is just water. So what we'll see is that 90% of our business is in electric machinery, and it's rotating machine, but it's also linear motion, it's sensors, solenoids, transformers, actuators, safety switches, and stuff like this. And so that's actually all, but we have more than 1,000 references through the world. It's quite big. I think I missed one part, but it doesn't matter. So that you know, we're part of the group. There is an office of the group in France, in the middle of the Alps. There is another one in Chemnitz, in Germany, and we're located, as I showed you, in Albany. And the group is about 80%. It's 60 to 80%, depending on the time. And the turnover last year, as far as I remember, was around 11 million euros. So let's talk back about Flux here. And it can solve the problem that are in static analysis, AC analysis, and transient. So static, that means we have a field that doesn't change, it stays the same all the time. So for example, to optimize laminations or things like this, flux path. AC analysis is where the signal is a sine function, and it's supposed to stay a sine function. And it's an approximation in the case of nonlinear problem, but it actually works quite well. And it's a place where we model in frequency and phase. And transient, and of course in transient we can do any type of application, whatever it is. And we use this for magnetics, electrics, and thermal, and all of this together. Some of the couple applications we can do, it's thermal magnetics and thermal electrics. So that's actually a very specific application for people who do induction heating, where the changes of, when you heat too much, the materials loses its permeability. And so that's what we would use to actually do this kind of stuff. We can also connect finite element and circuit, and finite element and motion, and eventually do some multi-physics, and as it goes along, we are actually connecting to other tools to do vibrations and other type of things, mechanics. Some of the little example here, this is a printer head, impact printer head, this is a resolver, so it's a sensor actually, it's a sensor device. This is actually more of a pivoting motion transformer. This is an information about skew. Today we can do skew in a fairly elegant way, so instead of doing a full 3D problem, we can take a 2D cross-section and duplicate it by just changing the relative position of the rotor to the stator to mimic the skew. So it's not a real 3D, but it's quite efficient and gives some really good results. And the last one on the right is also a sensor, and it's a speed sensor that involves eddy current. We'll talk a little more about sensors this afternoon. The step for modeling, and I think you all know this also probably, the only thing I'm going to talk about is the fact that we have the imports here, and that today we have a SAT import. It's all part of the kernel of ACES kernel. So we have SAT, we have CATIA, ProEngineer, Inventor, and of course standard import stuff such as IGES and STEP. And it's not probably in the next version, there will be also SolidWorks import that will be included. We have some mesh imports. Those mesh imports, we tend not to use it anymore, but they were used a lot by the recording head industry. And then on the outside, we have the export. Of course, we can export back to some of the CAD programs, but more we can actually export result to Excel, text, XML, XML being a web design type of tool. The result we can get, and I think probably most of you know those, you can have color-shaded map, so of anything, any value, any quantities. If you have something that you can compute, if you have a support, you can actually plot it on it. You can also have lines, so the lines are a little more difficult because the lines need to be probably in cross-section most of the time. I'm talking about 3D, of course in 2D there is no such problem. And then we have variation curves along paths, so I can define a path anywhere through my geometry, and out of there I can plot anything. I can compute it, I can display it. And time and special spectrum quantity. So when I do variation curve versus parameter, specifically time, I get then, for example, this is actually versus position. I get a curve which is periodic, and I can do an FFT analysis on it. And that's basically the FFT that you see on the bottom. So it can be a time FFT, it can be a space FFT, or it can be versus any parameters actually that you can think of. Other things we can do on the curves, and I will show you this a little later, you can actually integrate and you can derivate on the curve. So you can manipulate the curves also. Global quantities such as inductance, energy, forces, and torque, so we can compute all of those things. And just quickly, the way we compute the forces and torques is actually an interesting way. we're doing, it's not Maxwell tensors, and it's not the classical virtual work method, but it's a method where we're going to evaluate the energy from the shape function, and we will derivate it, and then only put the number in. So we are not as much sensitive to oscillation in the energy. So that's an important part. The other thing is we can connect to circuits, and I think most of you know this by now. Here is an example. This is a circuit inside Flux, actually, but you can also then connect outside to part1 and MATLAB Simulink. So here is an example of a PWM attached to a reactor or some kind of coils. And what we have here, the circuit, is it has a DC voltage source, it has the switches, and we are going to control those switches to mimic the PWM. The coils, we see them here, and they're connected basically to the finite element coils here and here. So, and once we solve this, so say it's solved, we put the voltage, and we want the current to be sinusoidal, and this is one of the results you can see. And if I do a little zoom on the picture right there, I can see the details of the switching. Because we want to do motion, so we have all rigid body or solid body motion. Okay, that's not mechanical or anything like this, but it is actually solid. I mean, it's not stress or strain, but it is motion. So what it means is that when I do rotating motion, translating motions, or pivoting motion, I can set an inertia, and I can let the program compute the motion from the sources from the magnetic problem. And I can also do free motion, but the free motion in this case is guided. So it's not a full mechanical connection, but it's guided. So for motion, we can do multi-position. The important part here is we don't have to remesh. So we're not going to have noise from the remeshing. We can do constant speed, and then we can do mechanical connection. So constant speed on a machine, we may use this to do a back EMF, for example, or we may use it to study some rated conditions. Now let's talk about version 11.1. And for people that have used Flux in the past, 11.1 is the very first version where everything is done into the same interface. So whether we are in 2D, in SKU, or in 3D, it's going to be exactly the same GUI from the beginning to the end. That brings a lot of new possibilities. The first one is that any parameter, any geometric parameter, which is entered in the preprocessor, will be available in the post-processor also. So I'll be able, for example, to define paths in my post-processing that use parameters so that they actually can be adapted to the parametric process. The geometric parameters are also available in the post-processor. That's important. And now we have also full scripting capabilities from beginning to end. And as a reminder, we're using a language which is called FLUX. And FLUX is a derivative of Python. Python is an open interpreted language. And if you ever need some information about it, python.org will give you some information about it. It's very comparable to maybe C or a similar type of language. And the interesting thing is that with this now we can actually create a whole process. And you can also create macros and other things like this. And then because we are in the same interface, now we can use sensor from the beginning to the end. So if we have some conditional event, we'll be able to look at the value of a current and switch on or switch off, something we could not do before directly in Flux. We had to go through third-party product. And now the 2D is also brought back inside the same environment. So this is some picture of the post-processing. And on top of it, this is pictures of the magnetothermal application. So this is a case, by the way, this is a funny, little funny example. For people who don't know how to cook an egg, here this is an example. This is working with an inductive stove. Maybe you know those inductive stoves. It's just a coil. And you need to have a special pot, that pan, that can actually couple with the inductive field. The inductive field is going to develop power in the bottom of the pot, right there. The pot is full of water, and in the middle we have a little leg. And so what we're trying to do is bring the water to boiling condition. And once it's in boiling condition, we're just trying to maintain the temperature. And this is what you are seeing here. This is the power which is delivered by the plate under the pot. And it starts warming up, and then it reaches the temperature. And now it's just going to trigger once in a while to maintain the temperature. And here is actually the temperature versus time. So if you need to know how it works in your pen and pots, or if you need to impress somebody, that's something you can do here. There are new commands in the supervisor, and those new commands include the possibility to define your own shortcut. So if you use the command many times and you don't want to actually go through mouse click and stuff like this, you can use a shortcut. There are a few that are already done, but you can add others. You can select a look. I'll show you this in a minute. And you can also define your own set of units. Other things is, in the supervisor, we bring now the most recent files. So I'll be able to see quickly what file I have accessed in the last 10 times. I can go up to whatever, I can define what I want. So that's also a cool thing. And not only do we have information about the file, but we have information about their size, the date where we use them, and the type of files. That's the possibility to preload macros. So we've introduced macros already a while ago. And those macros can be anything you want. You can actually define your own macro. We define macro. I'll give you a little later a list of all those macros. But today I think we have more than 80 macros to compute information on curves, to do repetitive information, do, for example, a mesh, do a mesh for a skin depth type of problem. And so you can have this macro being loaded automatically when you start the program. So you can customize your environment. I think just a couple of times. We'll see if this works. Let's go to the other part. Okay, it's time for me to do a demo. So let me try to do this. So this is the supervisor of Flux. And as we were talking before, right here you have a place where you have all the recent files. You can see those are the two files that are on that have been accessed. I only keep like a couple of them myself, but you can actually see them. It tells me they're Flux files, and it gives me their size. The environment, otherwise, the box of the supervisor didn't change very much. We have probably less information right there. We still have the three different environments, and you can see that when I go through another environment, it's going to filter the file, and for example, here it's going to give me the last access 3D files. Skewed, I guess I didn't do any on this at this point, but here is Flux. As before, if I actually go on one file, it's going to show me what it is associated to. I have still my directories that I can travel to. So we were talking about some customization. First, the unit. Right there, this is the unit that are available. I mean, this is the environment where you set the unit. So, for example, if I take a unit like forces, say here, force, and you can see I have newtons, I have din, I have ton force, pound force, and ounce force. So I can select, by default, it works in MKS, and you can actually choose whatever you want. So once you've set your default unit, it means that when you work, it will automatically use those units. If a unit is not there, and you're using a special unit, so we can actually create a new unit. I can give it a name. So for example, I can create a new weight, and let's call it the Taichung. And I can say I just need to then give the factor how many newton is a Taichung, and so I'm just going to put 25, for example. Or here I have 125, but let's put 25. And now this unit is ready to use. So if you have other units, you can do it. So let me just get out of here. I don't need to keep this. I talked about feel and look. So if I go to the, this is the option setting place. So the feel and look and feel, here it is. I have different way of displaying those characters. So I have cross-platform. I have motif, you can see. So all in the program in Flux is going to be displayed using this scheme. So maybe I can in fact try to use this one. I understand that the Mac is not very recommended, so try to avoid the look of the Mac. So let's just, I'll take the motif. What else? We talked about the macros. So you can see that by default it's loading a macros which is called mesh skin effect of a surface, well, of a face region. We'll look at it later. I will show you how it works. I can add as a macros if I want. So if I go look in Flux, there is a whole directory of macro which is delivered with the shipped with the software, and so you can access any of those that are here. And you can see there are some for Flux, 2D, 3D, some that are more associated to the materials, and then some that are just for functions around the software. So let's just keep this here. Other type of things here, this is where I can set how many files I want to be displayed and how many I want to be remembered. I can actually add some type of files so that Flux can actually recognize them. Some information on the memory. We now have a slider. Before we didn't have a slider, and you had to actually enter all the numbers and make sure you were doing pretty good. So now you can just slide to grab whatever memory you need to have. Multi-core. Flux uses multi-core. I will be talking of the post-process of the solver a little later. We'll just come back to this. And other information for people who use MATLAB, you need to actually set up here the MATLAB directory so that Flux knows how to call it whenever it is needed or when you start it. And I mean, I'm not going to go through all of this. Yes, a shortcut. I just wanted to show you the shortcuts. Here they are. So for example, we have a shortcut for new project, Control N, open a project, Control O, save, Control, etc. And if you want, you can enter any key sequence here. So let's just keep this here. And you can see I changed my look and feel. And this is how the whole program looks. I'm going to stay here because I'm going to do another demo in a minute. So one of the main development or things that we brought to Flux is the 2D sketcher. And so the 2D sketcher will actually let you enter geometry from very basic shapes and create the intersection and all of those things like this. Those are the shapes you can also copy. You can manipulate the geometry. So the elements are lines, four-sided structures, circles, arcs. You can edit, select, cut and paste, and so you can rubber band. I mean, you can select something on the screen, you can copy and move it around, you can move it anything. And you can make sure that you have the real geometry, because we have the possibility to do chamfer and fillet, something that were not there in the past. And you can create the infinite box by itself. So let's look at it. I'm going to do this after maybe this works on this. So I'll do two examples for you. I'll do a first example, which is going to be very easy, just kind of a pot-core type of structure. And I'll do after another example, which is a full rotating machine. So the first one is just to try to discover. So I'm going to start Flux 2D. So that's actually the 2D application of Flux. And by default, so I'm here, I can open a project. I'm going to say new. And when I do new, by default it's going to come in the sketcher. You can actually make sure that it doesn't come by default in sketcher if you don't want to use it. So let me just kind of grab anything here. Okay, I don't care. No. Here we go. So here is my my sketcher. I have here all the little information that I can, the little element that I can take. So I can actually bring those on the side, for example. That's the toolbar of my of the element. Then I can, for example, take, those are not this one, sorry. It doesn't want to take the one I want. Where is it? Right there. Okay. Some information, this is the display and things like this. And those are all the symmetries, etc. So let me just put it back here. Anyway, so let's do a little example. And first thing is a pot core. So the structure is going to be made of two different C-shape on top of each other with a coil in the middle. So to do my first C-shape geometry, I'm just going to create the bottom part, and you can see that as I move around my cursor right there, I have the information in the local unit of the position of the cursor. So right now I'm at 20 and -9, so I can go here. By the way, if I want to change something, so I can actually, I'm still in a rectangle input mode. If I want to actually make sure that this point is at the right location, I can double click on it, and then I can just say, okay, well, you know what, I want to have -10, and it should actually put it directly, okay? Or I can, of course, just draw the point also, as I go along. The points are attracted to little positions, and I can define the grid I want. And this is done inside here in option. That's the grid. And by the way, I can say yes, try to get to the closest corner, or no. And then I can give the length of a grid cell. This is this one. You can see this is 10 millimeters actually in this case. Subdivision in a cell that's here, I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then inside the cell, right there, I have a 10 by 10 matrix. So if I go, I can put, for example, put only 5, and you will see immediately that that changes. No, I'm actually attracted only to 5 of them. Okay, I have the first outside part of my on my C shape here. So here we're going to get the other part of the core. Maybe something like this. Okay. So once I have this, as I said, I can do chamferings or round. So let's do a little fillet. For example, between here and here, I don't want to have to have a corner. And I just can put, this is a chamfer, so the chamfer would actually give me just a flux. So I can say what's the distance at which I want to put it, and that's how it's going to change my geometry. But instead of a chamfer, I would like to have a fillet. And here is the fillet, same idea. I can do right mouse click, by the way, and all of this is local in my environment. So I can say fillet right here, and I'll just can see live. Okay, this is for 1, this is for 3, this is for 2, whatever I want. So I just put 1, for example, at this point. And then I'll do the same on the other side here. And again, we'll do a fillet here. We'll just do the same one. And then we'll do one on the outside. So by the way, when I select 2 lines, but I can do this in different way. I can either select the 2 lines first and then ask for it, or I can select nothing and just ask for it. And of course, to ask for it, I have to go pick it up here. So I say a fillet. I want between this line and this line. And now the radius, and the radius is going to be, let's put a little more, let's 2.5 for example. Okay, so now I have half of my structure. This line in the middle I'm not going to need, so I'm just going to, I just highlight it, and I click it, so it's dead. I can take this, I can move my structure, okay, I could normally. I can take this and I can move my structure around, as you can see. I can get it back here. Let's see, what else I want to do. Because I may do something else after, you know what, I really want to have a little block right there. And I'm going to do this right there, little square right there, and we'll see after what we can do with this. Automatically, the intersections are created. Now I have half of my domain. And let me just close this, I don't need it. And what I want is to do the other half. So to do the other half, I will select my whole domain, and I'm going to say I want a symmetry, and the symmetry is somewhere here, right there. I'm going to say build a symmetry. It has everything which is already selected, and the only thing I need to do is what's the line or the point of my symmetry. And in this case, I'm going to select this one, and you can see my geometry is all set. Now I can add the coil in the middle. And here we are. And I have almost finished my geometry. There is one more thing that I would like to do is just put an infinite box. And here we go, new infinite box. And I'll do a disk, and I cannot remember what is this. Let's just put, for example, 40 and 70. Just say OK. And here is my infinite box around. So for a reminder, this is a true open boundary problem. So that means that everything past this border is computed as if I was going to infinity. What it is using, it's doing a conformal mapping of the outer space within this band right there. By the way, little information, you can see the program says I cannot change those lines because those lines are actually a very special type of line. They were associated to the infinity box. So other things is that I'm doing an axisymmetric problem, so I'm only going to have half of it, and now I need to tell the program that yes, I want half of it, and this is done somewhere here. When I do the domain symmetry, I'm going to do a new symmetry. I'm going to say it's versus the y-axis, and I'm going to say that it is a tangential field symmetry. And you can see that immediately my box was actually cut. And now technically I would have to actually connect this and this. I don't like to do it, so I'm going to say domain. And I'm going to say infinite box, complete the box, and just say there is no mesh or anything like this. And here is my final product as it is inside Flux. And now at this point I can actually mesh my domain, and we'll talk of the mesh a little after, okay? So that's actually a fairly easy problem that we can do. You can see you can enter quickly. Let me show you, and by the way, let me get out of this. I don't like this environment. I like to see the way it was before. The gray is too sad for me. So let me just change this to the other way it was before. I'm going to go back to my look and feel, and I want I think it was maybe the system I had. So we're going to say, what's it system? Cross-platform. Here we go. Here, it's much happier. Oh, and you can see I'm actually getting close to using all of my disks. I'm going to have to be careful. So that being said, I want to show you quickly. So this was a very, very easy, basic problem. So let me show you how you can actually enter an induction machine, for example. Probably you don't believe I can do this, but let me show you that I do. Can do this with this environment. Here it is. I'm starting the program again and doing the new stuff, and it's in Sketcher. Here I can move my stuff. So induction machine. Well, how am I going to do this? Well, first let's just change the options here again. I'm going to just put 5 again. That's fine with me. It was more than I needed. Let's say I have 20 right there. So well, we can do an induction. It's going to be a small one. It's just for the principle to show you how it goes. So first thing, I'm going to take a circle to do the outer radius of the rotor. And I'm going to come here. And by the way, if I want to change it, I can put exactly the value. I could also enter a parameter here. It says that it's the outer radius of the rotor. And well, I could type in a better way, ORR. And then just put a value and say, okay, it's 22.5. Why not? I don't really care. And so that's the one I want here. You just clear and say it's what I want, okay? And here. And now my circle here is depending, of course, on this value I just entered. So let's enter another circle. That's going to be for the other side of the air gap. So I'll just do it to a value which is big enough, because otherwise we're not going to be able to see. So I'll go here for now. And again here, if I wanted, I could actually enter again. Sorry, escape. I could again enter something here. So it could be ORR plus so the gap, and I can say, for example, plus 1 millimeters. Yeah, why not? I can do this. Okay, it's ORR, no ER. Okay, just to show that even though I'm using a sketcher, I can still enter very precise information. So let's go back, and now we're going to enter the outside radius of the skater, so somewhere here, and I'm not going to put, make it again precise. You've understood by now what I'm trying to do. And then this is the shaft. So I basically have my laminations, my punching, but I don't have the slot. So let's work on the slot. And if I do a slot, I can actually get something. I'll start with a little square here. So that's going to be the slot opening. Actually, I'll do half of it. I don't have to do the full stuff. Now I'm going on the other side because eventually I'm going to cut this radius here. And then I'm going to do the other part of the slot. So look at something. When I'm close to another line, I can see the green line that shows me the alignment. Okay? So again here, I'm going to go from here and here. So that's going to be, let's see, I need to check a little my geometry. Here, so I can go maybe up to here. No, the slot is not the shape normally. Maybe it's going a little, and by the way, if I don't like it, I can always move the line here, okay? I can also, I don't have to stay with a rectangular element, and because the slot would not be a rectangular element, and then I can basically create a tilted part. So the slot is actually not square at the bottom. So here we're going to put a fillet. Semi-knees, a fillet, maybe 2, that's perfect. Okay, those are very, very small slots, but it doesn't matter, it's to just show you. And then inside here, this line here needs to be broken because I have an intersection here, so I can say break this line. And, oh, not here, I wanted to break it here, sorry, and here it is. And now I have those lines that are actually all inside each other. The other one here, I don't really care because I'm going to delete this part, and I'm going to also delete this part here. And this I don't need anymore. And this I don't need anymore either. It's finished. Here, I can also kind of change the orientation there and put it now sideways. And it's the same idea because in a real machine, I'm going to have a little fillet right here. So same idea as before, I'm going to do a very little fillet. So for example, let's start at 0.5. Okay, now I have my stator side. I'll do the rotor side, and let's just say I'm going to do close the slot. So I just need to have a square here. Take the square. Go and do, this is my slot. Maybe something like this. And now what do I want? I'm going to do, this one is going to go maybe a little further on the outside. And again, remember I can actually, I can give the number for each of those points. And now to finish this, I'm going to create a fillet from here to here. Chamfer fillet. So, and you can see as I try to fillet, okay, right now it's probably telling me it's too big. Okay, that's 1. I can do 1.2 or 1.5, whatever. As I do stuff, I can see live my final geometry. I have an immediate preview. And I'm saying okay. And then I'm going to do the same at the bottom here and here. And again, the fillet. And let's just say 0.4 maybe. No, I can do a little more. 0.8. Okay? Now I have 2 pieces of my slots. I'm going to do the other side. And by the way, I don't need this part of the circle anymore because I've done my intersection, and I'll re-enter it after. But I need to remove it because I'm going to do duplication. And for the duplication, I definitely need to have this. Okay, I'm missing. No, I'm not missing anything. Let's just take this half slot, those 2 geometry parts, and I'm going to do a symmetry. So the symmetry is somewhere you've seen it right before, right here. And I'll do a symmetry towards here. Now I have 1 rotor slot and 1 stator slot. So now let's just say I have a 24 slot stator. I'm going to take this, and I'm going to move this by rotation. The pivot point, it's asking me the center of the rotation. It's going to be 0, 0. And the angle between the repetition, so if I have 24, it's going to be 15. And I do need 23 of those. Okay, and here it is. You can see my stator is done. And now I'm going to do my rotor. Just select whatever I need. So it's important to zoom to make sure I have the right stuff. And same idea here. I'm going to be doing a duplication of this. The pivot point is still the 0, 0. Let's go out so we can see what happened. And let's say I have 24. Let's see if I can put maybe 32 of those. So I would add 31. And the angle would be 300. Oh, no, don't go away. Sorry. The angle would be 360 divided by 32. Okay, so that's maybe a little too much. So I'm going to do just do 27. I'll do 27 and divide it by 27. Okay, still too much. All right. There we go. We're all set with this. And now the only thing that I would have to do is actually close this, this slot, which I haven't done. And that's actually done with the narco circles, where I'm going to come from here, and then I go from this point to this point. And now this line, again, I can actually duplicate it as I duplicated before. The pivot point is still the same, right here. And the angle is 15, and I'm going up 15, 1.5 only, and I need to do it 23 times. Okay, and my geometry is all set. I can close, and if all is well, I can actually mesh this. Yeah, it's done, and I can mesh this immediately. And here we go. And it's going to be time for me to actually stop right as soon as I have this mesh done. And here, this geometry is now ready to be processed. At this point, I can actually enter the physical properties and all the mechanical stuff. I think we have a Rex. Can you let us